All right, last example. We'll factor the numerator, and I know there's a GCF of x, and when I factor that out, I'm going to be left with x squared minus 9, which is difference of squares. So x plus 3, x minus 3. In the denominator, there's a GCF of 3, and when I factor that out, hold on, I'm going to be left with x squared minus 2x minus 3. And that will factor to x minus 3, x plus 1. Okay. Any holes? Yep, there's a factor of x minus 3 in the numerator and denominator. So at x equals 3, we're going to have a hole in our graph, and we'll denote that with an open circle. Vertical asymptotes? Yep, we're going to have x plus 1, so x equals negative 1 is a vertical asymptote. In this case, for horizontal asymptote, the exponent is larger in the numerator, so that means that there's going to be no horizontal asymptote. However, we will check for an oblique or slant asymptote. X-intercepts, yes, there's a few of them actually, right? So there's going to be 0, 0, and that comes from the factor of 0. We're going to have negative 3 comma 0. And then we will not have an x-intercept at 3 because that's where a hole exists. For a y-intercept, put 0 in for x. We get 0 over negative 9, which is 0, 0. So plotting what we know, there's a vertical asymptote at negative 1. We have no horizontal asymptote. X-intercepts at 0, 0, and at negative 3. And then we have a hole at x equals 3. So what we want to do is figure out an oblique asymptote or a slant. So it's going to be kind of slanted or this way. We don't quite know yet. But once again, we'll do that with division. So we're going to take 3x squared minus 6x minus 9. And then our divisor, or dividend, sorry, is x cubed plus 0x squared minus 9x plus 0. So don't forget those placeholders. Okay, so 3x squared times what gets us 1/3, or x cubed is 1/3 x. And so at that point we'll get x cubed minus 2x minus 3. When we subtract, we'll change the sign and add. So the x cubes cancel. 2x squared minus 6x plus 0. Then it's 3x squared times what gets us 2x squared. That would be 2/3. So 2/3 of 3 is 2, 2x squared. And then 2/3 times negative 6 is negative 4x. And then 2/3 of negative 9 is negative 6. Change your sign and add. We end with negative 2x plus 6. This is our remainder because the degree is smaller than that of the divisor. We're going to ignore this. And then our quotient, 1/3 x plus 2/3, is the location for our slant asymptote or our oblique asymptote. Okay, so horizontal asymptote, we don't have one, but we do have a slant at 1/3 x plus 2/3. Okay, we want to find some points to plot. I know it has a rational y-intercept, so maybe I try like at negative Oh no, let's try maybe x equals 3. Should we try that? Oh, 1. Let's just do 1. Okay. So if x were 1, then it would be 1/3 plus 2/3, 3/3, or 1. So our oblique asymptote passes through 1, 1. And then we can use our slope of 1/3 to say up 1 over 3, up 1 over 3, or down 1, left 3, left 3. Okay. With those, we're going to put in our dotted oblique asymptote. And we actually have enough points that we don't need to test anymore. And that's because we have a point located on each side of a vertical asymptote. So on the left-hand side, we have this x-intercept of -3. So we know our graph comes down the vertical asymptote, passes through that x-intercept, and then flattens out along our slant. And then on the right-hand side, the graph comes up along the vertical asymptote, passes through the origin, and then continues along that slant. Okay, that's it.